All right, good evening, anyone. As promised, I am going to do parts of chapter 2, not everything. It is quite a long chapter, and I'm going to go over some of the things. I did upload this Jeopardy review on Canvas under files, and I also had some sample work problems that you might encounter as you are working through Pearson. Now, the numbers obviously don't match, but the problems are very similar to what you will encounter. All right, let me go over some of these questions. Let's grab some pens here and do some things. Okay, so when it comes to symmetry, let me zoom in for a bit. Again, I'm not going to do them all. All right, and here are definitely some of the answers that you can already tell. All right, when you are looking to see what and how you graph a symmetry with respect to the y-axis, it basically tells you if you were to reflect this over this side, here's the y-axis, so you have to first know where the y-axis is found. Hopefully you know how to figure that out. Okay, so when it says reflect this across the y-axis, it basically is telling you to fold this paper right through the middle, okay, and fold it and have this reflect on this side. So this were to reflect, how would that go? I don't understand why I had so many pages. I'm not sure why. Anyway, so if you were to reflect it, this dot would go exactly the same. So you just look at the distance. It's 1 unit away this way. So that would go here. This dot over here is 2 units away from the y-axis. So you go 2 units this way, and that would be here. This dot right here, just pick a couple of points. That one is 1, 2, 3 units away from the y-axis, 1, 2, 3. Or you can say it's 2 units away from this dot, which is fine. And then this dot over here, that's 5 units away. 1, 2, 3, 4, 5. And then you just connect the dots the same way. And that's why the reflection would be what's on the bottom. I don't know what my computer did. I asked for, maybe that's why I got so many pages. I'm not sure. But if I zoom out a bit, it doubled up my questions. I'm not sure why. Why I got so many pages. The answer is not here. The answer is over here on the back. It did 4 copies of the same question. Okay, well, that's fine. Well, the answer is on the back. And this would be the final answer. You just connect it. Okay, again, this Jeopardy review is on Canvas. Right, I don't know what my computer did. It did 4 of the same one. Well, now I have enough to write and discard. All right, the next one says, make this function an odd function by drawing the missing part. I will not have this type of question on the test. However, I did want to go over this. An odd function means that you are going to basically reflect this across the origin. So it's as if I made this, oh God, that was horrible. I guess the computer printed out 4 of these in case I messed up. Let's try it. Let's try this again. So if I have the x-axis and then the y, and I had a line that was y equals x, which now you should know how to graph. How does it take each of these dots? Basically, what it does is if you take any dot, any of these dots on the graph, any dot that is x, y, will go and will become negative x, negative y. So what I'm saying is any dot, whatever the sign is, change the signs and it'll get you the dot on the other side, which will be reflection and making it odd. Okay, this will not be on the test, but this is understanding how a function becomes an odd. And that's why the answer you see on the Jeopardy, you'll see this to be the odd graph. Okay, so if I were to take this dot, let's say that's this is a 1. Let's say that's 2. So let's say this is 1, 2. If I change the signs on both of them, that'll become -1, -2. And that's why the dot down here is -1, -2. So basically you take a couple of dots, the lows and the highs, and maybe a couple in between. You change their signs, you plot them, and then you connect it, and that'll give you the odd. Okay, so this is just a brief description of what odd functions look like graphically and how they become what they become. So when you go through the lesson, it should be a little bit easier to understand why a function reflects a certain way to become this graph over here. And again, that's because you changed the signs on every single point. Okay, let me just make sure I'm recording because I might forget. Yes, okay, I'm recording. All right, and should be sharing. Yes, it is sharing. Okay. All right, the next one says determine if the function is even, odd, or neither. So I wrote the instructions the way that you should always start. You should always start by doing even. I can't believe I wasted so much ink. I'm so mad. So you start off with your original function. And when you look at, again, the media and at all the work that is required to figure this out, please make sure that you read the instructions, you follow the instructions. Okay, so first things first, you need to plug in a -x. -x everywhere x used to be on the right-hand side. So this will be -x to the 5th plus 3, -x to the 3rd. Now, anytime you take a negative power, so right now ignore the x, a negative number, not a power, a negative number to an odd power, that negative is going to come out. Okay, when you have an even, it's going to get lost. So in this case, you're going to get -x to the 5th plus 3 times every time you get a negative with an odd power, it's going to be -x cubed. So this is going to be the same thing as -x to the 5th minus, because I'm just moving this over here, 3x to the 3rd. Now the question is this function exactly the same as this one? The answer is no. So when you plug in a -x into the right-hand side and you do not end up with the same things, then that means this is not even. So you would cross off not even. So this is not even. If you would have ended up with the same exact function, it would have been even. All right, so then what you do, you take this function and you take out a negative. So you factor out a negative from each of the terms. So when I pull out this negative outside, I'm going to be left with x to the 5th. And when I take out this negative, it's going to become positive, and that's going to be that. So if this inside is the original function, so when you plug in a -x, and after you pull out, if it was not even, then you move on to the next step to test if it's odd. If you end up pulling a negative out and that gives you the original, if it's a negative of the original, then it means it is odd. Let's say you pulled out a negative and the function in here is not the original, then it would be neither. So you always start plugging in a negative f of x. You check if it's the original, check if it's even. If it's not, pull out a negative. If the inside is not the original, then it's neither. If it is, it's odd. Okay? And you could definitely graph this and notice that it reflects across the origin. Okay? And therefore, the work is here. Okay? So that just verifies what I just did. I just explained it a little bit better. Okay? All right, let's go to the next one. This one says determine if the function is even, odd, or neither. Again, so you plug in a -x. Okay. Oh, I didn't do it. Sorry. Negative, negative, negative. Okay, so when you have an odd power, the negative comes out. You can drop the parentheses, negative comes out. When it's an even power, it gets lost. negative stays plus 1. You compare this to the original. That is not the original, so it's not even. Okay, so not even. You're going to test it for odd by factoring out a negative. So when you take out a negative from all these terms, all the signs are going to change. So that's going to become positive. That's going to become negative. That's going to become positive, and that's going to become negative. And then you check, is this the original? Nope, that's off, and that one's off. So this is not odd. Therefore, it's neither. It's not even nor odd. Okay, and you can check graphically for the odd functions, like this one, like the previous one, for the odd functions. When you graph them, the graph would look something like that. You would have all the dots on this side be reflected over here on this side across this y equals x line. For the even ones, you would have all your graphs reflect across the y-axis. Okay, so this right here is an even graph because it reflects across the y-axis. Okay, for odd functions, they reflect across the y equals x line. Okay, all right, so this is an odd, this is a neither, and this is a neither, all right, because if I do the y equals x, sorry, the y-axis, this is not a reflection. This does not reflect down here, right? It would reflect up here. So that's not even, and it's not reflected across the y equals x either, because all these dots are supposed to reflect down here and they don't. Think of the reflection line as a mirror image. Like if you were in kindergarten, you were to flip the paper and just bend it over there, this would have to reflect on this side, which it doesn't. Okay. All right, the next one would be state the following: even, odd, or neither. Find the domain and the range, increase, decrease. This is what we went over today. Again, I don't know why I have to. Oh my God, it's so frustrating. It's fine, I guess. It's fine. It'll just be seeing double. All right, so is this even, odd, or neither? Clearly, this is neither. Okay, so it's none of those. Domain and range. Let's do the domain. Okay, the domain is how far left and right it goes. Remember, these are arrowheads, by the way. Okay, I couldn't put them, so I had to do these myself. And so it's supposed to be negative infinity to positive infinity. It goes from left and right forever. You cannot close this up. And the range, if you're trying to put stop to this keeps pushing it down. So it's coming from negative infinity. All the y values from here are getting caught up. But if I move this up, and I right here, that's the highest it goes. So the highest it'll go, the only line I can put is a y equals 4. So it's going to come from negative infinity and it's going to stop at 4. And it's going to include 4. Okay. That's what I'm going to have. All right, for the increase, decrease, let's put increase, decrease, constant. All right, I start left, right. Okay, so I start left and I stop right here. That's a negative one. So I am coming from negative infinity all the way to 1. What is it doing? It is increasing. I'm going to put that here. From negative infinity all the way to negative 1, it is increasing. So that's why I put ink. Then from here to here, it goes down and then it goes up. So here it stops. So from this part to this part, from negative 1 to 0, it decreases. So I'm going to go to decrease. So from negative 1 to 0, it decreases. Okay, then from 0 to that number, which is 2, okay, those x values from 0 to 2, it's going to increase. So then I put union 0, comma 2. Okay, from 0 to 2, it's going to increase. And then from 2 all the way to infinity, it's going to be constant. So when I put constant, I put 2 to infinity, but I have to put a parentheses because that's a whole. And that infinity over here always has a parentheses. Okay, so this is constant. This is increase. And this part right here is decrease. I don't know if you can see it. Okay, so you always read them left to right. Increase, decrease, increase, constant. Okay, I hope that helps. And then the answers are on the back. Okay, you can see that there. Oh, I'm just so bothered with this whole situation. I swear. And so as you can tell on the answers, I just put parentheses all over the place. Okay, but again, I'm not, when it comes to the increase, decrease, I'm not like caught up on the whole parentheses. These matter, the domain and the range matter, but not these. Increase, decrease, that's fine, depends on the book. All right, for this one says, given a function, y equals a state the general. Okay, so this one just says how, and again, this is hard to see it. Check out the Jeopardy that I sent out. And it just basically states how the A, the H, and the K make a graph move. These is just general. Again, this is very dark, even though I put black and white. And then the answers are here in the back, okay? Let that be a guide. All right, for this one, state the parent graph. So the parent graph, you basically remove the H, the K, and you make that a 1. So the parent is y equals x cubed. The transformations would be this 2. So A is 2. H is the opposite. So that's a positive 1. K is 5. And then you write the sentence. You write how they move. All right, let's start with the 1. This one moves left, right. And the K moves up, down. So if it's positive, it goes to the right. If it's positive, it goes up. So it's going to move 1 unit right, move 5 units up. Okay. Let me zoom out. All right. This last one, we talked about it briefly today. If it's a number bigger than 1, it's going to vertically stretch. By 2. If it were a number between a fraction between 0 and 1, it would be a horizontal shrink. Horizontal and then shrink. Okay. All right, the next one, these were a bit difficult for students. Again, the ones that I try to put on the homework weren't that bad, but basically you're describing what's going on. So from here to here, I try to make it as easy as possible. This is a parabola. Okay, this is the y equals x squared. That's the parent graph. Okay, you have to know it's a parabola. You want to describe what happened. So from here to here, what happened? Okay. You want to say that it went this dot. You just basically take a point. You don't have to look at the entire graph. This graph went over 4 units and went up 2. So went over 4 and then up 2. So you would write y equals ax minus h squared plus k. My horizontal movement was 4. You enter it as the opposite, remember? So this is a 4. If there was a positive, that's going to look like a negative. Okay. The K, it went up 2, so that one just copy it as is. And I didn't, because these are hard to tell, I didn't change the width of it. Notice that it's the same width, so that's just 1. And that would be the equation of that transformed equation. simple as that. And the problems on the homework, I try to make them so that they wouldn't be super confusing. Oh, and I forgot. Oh my goodness. The width didn't change, but it is flipped upside down. So there is a negative. I forgot about that. My goodness. So this is the new equation. Should have put that in pink. All right. Okay, what is this one? This one, I show you the parent graph of the cubic. The cubic is right here and you can see it. Okay, the cubic, and then I ask you to graph this. So basically you're gonna do and describe the same thing. You're gonna say what this number does, what this negative. So this negative just flips it across the x-axis. This -6 is gonna bring it down by 6, okay? And that's what you should see down here. All right, again, watch not the recording, watch the PowerPoint that I sent. And I apologize for this being so dark. So you should be able to see it better on the Jeopardy PDF that I sent out. Okay, let's go over some of these questions. This one is, just following the instructions. So I know you can do that. You're gonna grab this. So grab a couple of points. This is how you would do it. You would just grab a couple of points. You can graph this in your calculator. I did it on Desmos to show this and to put it here. I would want you to move it 2 units to the left, move it 3 units up, reflect it across the X. So you would just follow the instructions. And again, if you have questions, we will go over this one as to how it ends up here. Okay. One of the things that I do have to explain is the fact that when you have an equation and you have a negative, like when A is negative, it says to reflect. This is what the book says. And all the books say this. It's a reflection across the x-axis. So you're basically going to grab this and flip it this way. So it's going to look like this, right? But that is assuming that there has been no horizontal or vertical shift at all. That's what it is assuming, okay? So be really careful because that's what it is if you are having no H, no X, no H or K at all. You just basically reflect it. However, if you have already moved it H and K units, it's not a reflection across the x-axis. It is a reflection across its vertex. Okay, so this vertex right here moved 2 left, it went 2 left, and then went up 3, and then normally it would have been like that, but that's why it ended up like that. Okay, because this dot, this blue graph that I'm going to draw, this went over 2 to the left, 1, 2, and then up 4 or 3, I think, and then it went upside down. Oops, I don't want to draw it in the same color. And then it flipped across its vertex. Okay, so from the blue to the pink, it flipped across its vertex, not across the x-axis, because a lot of students will say, oh, okay, I have it here, and then they flip it, so this ends up way down here, and that's not how it's supposed to be. It's very deceiving, I understand that, and that's the way the books have done it. So I think that part is very deceiving, and I just wanted to clarify this. When you look at the domain and the range of both of these, make sure that you know the difference. So the domain of this one, you start it here at 0, okay? And it goes out to infinity, which is 0, infinity. The range starts from 0 and goes up to infinity. The pink one, you start it here at -2, and it goes to infinity. And then the range comes from -infinity up to 3. That's the highest it goes. Okay, so make sure you do not put 3, -infinity. That's not correct, because that is not small to big. All right, so be careful with those things. Make sure you watch the recordings, you watch the media, and you go ahead and do those. Okay, I am going to do some absolute value questions fairly quickly. And because I haven't done any of those, the piecewise composition, I will do some of those. And then the review questions, I'm not going to do. The review questions are basically chapter 1. Okay, so I will leave that for you to practice. Use your time wisely. Now, when you have, and this is in my notes, okay, this is definitely my notes. When you have absolute value of some equation, and I'm going to put a big X, that means that could be an equation. You see it as one variable, but it's basically an equation equal to a number. I'm going to put that's not a hashtag, it's actually a number. When it's equal to a number, the way you split this into two equations as write down what you see without the bars. You put an or in the middle, and then you write down what you see and you make the right side negative. So when I try to solve this, 2x plus 10 equals 20. And you've done this before, hopefully. Even if it was a long time ago, it's something that you've been able to hopefully recognize. You do two equations. 2x plus 10 equals 20. You cannot solve it, the bars are there. And you have to end up with two equations. Okay, one of them has a positive 20, the other one has a negative 20. Don't be lazy and think that once you get this answer, you're like, oh, if I get x equals 2, I can just say the other one's negative 2. That's incorrect, okay? And you have to do both. And you also have to show work on this test. So make sure you know that. I subtract 10, 2x equals 10, so x equals 5. If you assume that this is going to be x equals negative 5, you're incorrect. So please don't do that. Do the work. Negative 10. This is not going to be 10. This is going to be negative 30. And when you get x, it's negative 15. See, told you this is not correct. There's no need to graph these because these are just two dots on a horizontal line. So those are your answers. Okay. This is for absolute value equations. Those are the answers. Okay. My ink is done. All right, when you're dealing with these, I'm going to get you started on this. This is also absolute value. The only thing you have to remember is that the absolute value bars need to be isolated, just like I had it here. So if the absolute values are not isolated and you got stuff on the outside or on the left side or on the right, you need to get rid of the stuff there before you begin working with this problem. So if I have the equation 2, 3x plus 4 plus 5 equals 16. Pretend this whole thing right here, let's cover this up. Pretend that whole thing right there is a variable. So if that were a variable, if that were a variable, how would you solve for that absolute value? You'd subtract the 5 and then divide by 2. That's exactly what we're going to do. So it gives me 3x plus 4. Then I get 16 and subtract 5. So that is 11. Okay. Then I divide by 2. So I am going to now have this isolated. Okay. And now you do what I did over here in the way you split. Okay. You make one equation by dropping the bars. That's one equation. And the second equation is dropping the bars and making this negative and solving. Okay. Then split to solve. Okay. The splitting means two equations. Don't just do one. It will be incorrect. When you solve, you should be able to get these two answers. So you go ahead and you do that and you come with your questions on Thursday. All right, this next one. Let me just move the ones I don't need. Oh my. Okay, these are, this is on the notes, but these are inequalities with absolute bars, absolute value bars, okay? So when you have one of these, you want to be able to know what kind of symbol this is. This is a less than. So when you are dealing with less thans, you're going to remember less than. Why this? Because you're going to have to know that this is an and problem. So the way you split it up is the following way. You do the same thing that I kind of did with the equality sign. You're just going to have to remember one more thing. So when you split this up, you copy exactly what you see. The first one is always copy what you see, right? The second one, you copy what you see. You make the right side negative, but in this case, you flip the inequality. You don't flip, there's no need to flip here because an equal sign, no matter how you flip it, is still an equal sign, okay? But when you're dealing with these inequalities, you copy and paste what you see without the bars, and then you make another one by flipping the inequality to the other side, and then you make this side negative. You also put an and in the middle, which is why this is called a less than. It's a less than, but I'm putting it down so that you remember it that way. And you solve. Okay, so I'm not going to solve each of them. When you solve the graph, again, watch my notes, look at my notes. When you graph an and, it's supposed to be in such a way that when you graph, one of them will go that way and the other one will go this way. So the shading will be in the middle. That's why it's called an and, because they're going to meet in the middle. Okay. Go ahead and solve that. I'm just giving you hints here in such a way that you get this answer. Okay, this is an interval notation. This is in roster notation. These two are the same answers. This answer and this answer are the same. This is in roster. And this one is an interval. Okay, hard to see, but that says interval. All right, this next one is a great tour. Don't get on my case for spelling. It's an or problem. So you do exactly the same thing in the sense that you have your absolute value bars, 2x plus 1 greater than 5. You do the split, knowing that this is a greater, a greater than, right? So you copy and paste what you see exactly the same way. The next one, just like I told you, flip the inequality, change the sign, so nothing different. But in the middle, you're going to put an or. And you solve. You solve them separately. When you graph an or, the or is going to come out to graph opposite ways. That's why it's called an or, because it's either one side or the other. Okay, so your graph should come out like that. Practice the problems on the homework, please. Your answer is here. Okay, so this is an or, this is the answer. Oh, I even did the work for you. Okay, some students make this negative, this left side negative, other students make the 5 negative, it doesn't matter. And this right here is interval notation. Again, look at that page 13 on the book. Okay. All right, this is, okay. All right, so for this one, you're gonna take this equation. First, you're going to take this equation, solve it analytically. Notice how I put solve analytically. So you solve it by hand, and then these you solve by graphing. So I'll explain how that goes. This is the same thing as that. Okay, so I'm going to take this A, and I'm going to solve it. So the absolute value bars. Okay, I need to isolate these. I definitely need to isolate. So I'm going to subtract the 3. Okay, I'm going to divide by a negative. Okay, at this point, I do the split, right? So I have x minus 2 equals 5, x minus 2 equals negative 5. From this side, I get x equals 7, right? From this side, I get x equals negative 3. All right, so I get 2 dots. Now, if you're looking at the explanation of graphs and how these work, please be sure to check out the graphs and the visual representations that we went over today. These 2 dots mean that this is a solution. These are the 2 solutions that make this statement true. When you're dealing with inequalities, please, 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 when I say solve graphically, do not go and do this, okay? Because this is solve analytically, this is solve graphically. And the whole point of this, if you look on this side, okay, the whole point of this is to use the answers that you already got. So you know that it's negative 3, 7 are the answers. That means that when you look at this right here, I'm going to copy it. I'm going to copy it. I can't even do this upside down. Y equals negative bar x minus 2 plus 3. Oh no, equals negative 2. Okay, this part. Not here. When you are solving these graphically, this is what it's saying. It's saying, where does this graph meet this one? So what you do is you plug in this entire equation as y1 in your calculator, and you plug this in as y2 in your calculator, and you see where they meet. So if you look at what I have here, let me zoom in a bit. This was done on Desmos. This would be like y1 on your calculator. That graph is this pink one. Like that. This y equals negative 2 is the blue one. Okay, so negative 3 and 7 are my answers. That's what it looks like graphically. So if I'm trying to find now, if I look at the back, which is hard to do. If I'm trying to find this greater than negative 2, I'm trying to find where the pink one, because this is a pink one, where the pink one is above the blue one. Where is this? Because that has a bigger, that has the bigger mouth. Where is the pink one above the blue? So if I have this graph in part B, the pink part is above the blue line between negative 3 and 7. That's why the answer is from negative 3 and 7. You don't really need to include brackets. I mean, this is, again, well, the reason why you don't include them, the reason why you don't include the brackets is because this doesn't have an underline, okay? So that's why you put parentheses. And then the parts where, the third part, C, where the pink one is below the blue one, okay? Or equal to. So the part where the pink is below the blue one are these 2 spaces. So the top part is B and the bottom part is the answer for C. And so you would state, oh, it's from negative infinity all the way to negative 3, and you put a bracket because the inequality had an equal sign underneath. So that's a bracket. Union because there's a gap. So it's from this part, nothing in the middle, and then 7 to infinity. And that's how you do these graphically, okay? So there will be a question on the test like this. Make sure you know how to do it. When I ask graphically, it means you have to plot the graph, obviously, and then state the answer by showing the work like this. Okay. All right, these are not difficult. These are all compositions. I hope to get through these fast. Okay, when I ask you, let's say, to find f of 0, there are 3 different equations that you have, but it will not, you won't plug in a 0 into all 3. It depends on the restriction. This is my x value, okay? So if x is less than -1, you would use this equation. If x is between -1 and 1, you would use this equation. If x is greater than 1, you would use this equation. That's all it's saying. So x is between this one, or this one. So which one is it? It's between -1 and 1. And so you would just plug this number into here. So that is the answer. There's nothing that you do. If I wanted to find f of 5, 5 is greater than 1. So I would use this equation. So I would go 5 minus 1 squared, 4 squared, 16. The algebra is not difficult at all. It's just trying to figure out where things go. F -12, that number is less than -1, so that goes in here. 2 minus a -12, which is 2 plus 12, which is 14. Okay? So when you are given these, that's not the difficult part. It's knowing where it goes. Once you figure out where it goes, you just do the math. Okay? And those are the answers that you see in the back. All right, the next one says, let's see if I have any more of these graphs. I could have sworn I saw these. These are piecewise functions. This is graphing them. You will not be having any of the Pythagorean theorem on the exam, that's for sure. And I forgot to check if they were piecewise functions. Maybe the simple ones. Okay, but let's go on to, no, let's continue with, let's just finish this off. All right, for piecewise functions, you're basically graphing these. So you would put these on the calculator and just cut it from where it says. So let's just go through the answer here. This 0, x equals, so you basically you have y equals 0, y equals that, y equals, you've got 3 different graphs. And all you have to do is cut them. So this is a cut, a vertical line at x equals -4. So this is a line all the way like that. That's this graph, okay? That's this line, but it's gonna get cut at -4. So I find it, boom, I cut it. And I only keep what is less than -4, which would be this side. It is an open circle because that is a less than with no bar underneath. So that first graph in blue, that's this one. I'll number them, okay? The next one is a negative absolute value of x. That graph is originally, if I were to graph it fully, it's an upside down V. V for absolute value. This one, so if you're looking at my penciled graph here, that's the original full graph. But it tells me to make 2 cuts at -4 and 0. And I'm going to keep everything that's between -4 and 0. So always think that these are in between. So I'm going to keep whatever is between -4 and 0. So I'm going to grab my pencil, make a cut at -4, 0, which is this line. And I'm going to keep everything. So everything after that will be gone. This is probably better explained with the medium. I'm going to do a pink color. I don't know if this will show up. On the 4, it is a closed circle because that has a bar underneath, but on the 0, 2. So that's that graph. That's why you have this line that looks like that. Again, you can see it better on my PDF. All right, and I can erase the cuts now. The last one is an upside down parabola. If you were to graph it fully, it would look like that. But this is take a cut at 0, and you're going to keep everything that's greater than 0. So it's everything to the right, which is why they only have one side of the parabola. Oh, that was number 2. And number 3 could be done in, I don't have another color that shows up. Let's say green. That would be an open circle with this. Okay, that's an open circle. Now you can see it better on these. Okay, but that's what it would be. So you basically cut it at those points and then keep those parts. Whatever it tells you on this side, that's where you cut and you keep. You cut and you keep. All right, that ends the function notation. No, sorry, the composition. All right, function notation is fairly easy, and I want to go through these fairly quickly. They're very easy. They are just adding, subtracting. It's just different ways of writing these, okay? Whenever you encounter, and I give you the definitions here, I don't even have to write them down. When they tell you find f minus g of x, it's the same thing as getting f of x and subtracting g of x. You basically subtract the functions. So it says, given the functions above, find the operations. I want you to find their subtraction and their addition. The most important part is follow the order. So f of x minus g of x. I'm going to take this and subtract g of x, which is that. Do the math. 5x plus 1 minus 2x. This is not multiplication, by the way. Please don't mess that up. And you put the like terms together. That's a loner. This one with this one is 12x, and then that is a negative 5. That is the subtraction of f minus g. That's number 1. That was it. The second one tells me to add them, f plus g. So I do 5x plus 1 plus 3x squared minus 7x plus 6. And I just do the math. There's nothing to change, meaning any of the signs. You only change them when you're subtracting. Okay, so I just do the math. 3x squared minus 2x, and then that's a 7. That's what happens when you add and subtract functions. Just make sure you maintain the order, you show your work, and that should match the answers on this side. Okay. Yeah, there was one I made a mistake. Oh, this is the one I made a mistake. Yeah, the answer on this, that's a plus. That was a plus. Okay, so anyway, just make that change and you'll be good. Rewind the recording if needed. All right, this one is multiplication. You can clearly see a dot. If you see a closed dot, that means multiplication. If you see division, you do division. So for number 1 and number 2, for number 1, you're going to take f and multiply it times g. So you have to FOIL. Negative 2x squared minus x cubed plus 8x plus 4x squared. And you can just put these two together and you're done. Put them in descending order. And that's pretty much it. Just follow the order, multiply, distribute, add like terms. Done. F divided by g, so you're going to do f of x divided by g of x. F of x is negative x plus 4. That's one function divided by 2x plus x squared. That's the other one. Do not, please do not cancel things like that. That's very illegal. Okay. You will learn later on, you should have learned this already, but anyway, this is a complete function. If this entire function is not exactly the same as the bottom, you do not cancel. The only thing you can do here at the bottom is factor an x, because that's what they both have in common. And you still notice that you still can't cancel these groups because they're not exactly the same. So it doesn't matter what answer you give, you'll get full credit. Just do not cancel anything that you are not even sure of. Okay, I'd rather you leave it like that and get full points rather than you try to cancel and then get points taken off. All right, and that's again right here. And then I just gave the domain and range of what things are allowed and what things are not allowed. Go through that over the Pearson. All right, last one. This is the one that students have trouble with. This is composition. So you're going to plug in one into the other. All right, this is the first one and this is the second one. Oh, it's two blues, I'm sorry. Okay, this is a circle. That circle does not mean multiply. I repeat, it does not mean multiply. Please do not multiply, okay? It means you're gonna plug in F into G. So let's say that, let's just do this one out. Hope it doesn't come out ugly. Yeah, does it look yellow? Yes, it looks yellow. Okay, and then we'll do the other one. Let's see how ugly this turns out. We'll do orange. Orange. Okay, so I want you to find f of g of x. F of g of x. So g is yellow. G is yellow. F of x is orange. Okay, so for the first one, number one, it tells you to do f of g of x. So I'm gonna have the highlighters. F of, I don't know if you can see it. I think you can. I know it's hard to see, but that is g of x, okay? So you're gonna take g of x, whatever that's equal to, and plug it in here. So that's gonna look like this. So the first step is always very easy for students. They're like, oh, okay, I need to, let's g of x. I'm just gonna go to g of x, see what it's equal to, copy, paste, and that's what I end up, okay? Copy, paste. The second step is going to the orange function, the f of x, and plugging this in wherever x is on the right side. So that's going to be 2 squared plus 3. Whatever you plug in here is going to be here. So that's x plus 7. Oh dear, it's supposed to be, oh, I'm so sorry. Oh God, I just messed it up. This is supposed to be yellow because that's where I'm plugging this in. This function is supposed to be the orange one. Okay, and so then you do the math. Do not distribute this 2 because you have to FOIL first. So this is like having 2x plus 7, x plus 7 plus 3. You have to FOIL first. Don't forget to do that. I'm going to FOIL this out. X squared plus 14x plus 49. I skipped a step, by the way, just FYI. Distribute the 2. 2x squared plus 20x plus, what's 49? 898 plus 3. And the only thing you can do is add these two together. Okay, so f of g of x equals 2x squared plus 28x plus 101. Okay, that should be the answer. Yeah. That was the hardest part because you had to square that. If we do the second one, which is g of f of x, there's always one easier one and one harder one. Okay, I'm basically, let's do that at g. I'm gonna go to the g function. And plug in my f function, which is 2x squared plus 3. That's an orange. So now this sends me to the yellow function. So I'm going to go to the g function and plug this whole thing in for here. Okay, so that's going to be 2x squared plus 3. That's this little piece, and I'm just going to add 7. That one was much easier. All you have to do is literally add 7. This parentheses I just put so that you could see that that was this piece. But it's just 2x squared plus 10. So g of f of x equals 2x squared plus 10. Make sure that you practice this because this is very confusing for students. I try to color code and to help you out. The answers are on the back. All right, the review questions I'm not going to go over. However, I did want to go over the last one, which is a word problem, and that will be the last one. Okay. So what I have here is I have a table, and you guys are welcome to use it. You guys are welcome to do it. The formula is RTD. Rate times time equals distance. So I know it's hard to read, but you can definitely close it from the Jeopardy. It says, a car went 372 miles in 6 hours, traveling part of the time at 55 miles per hour and part of the time at 70 miles per hour. How long did the car travel at each speed? Okay, so this car is going, let's say, from point A to point B. Okay, and it does some traveling, like let's say it's a total of 372 miles, that's distance, for 6 hours, and it's traveling part of it at 55 and the other part at 70. Okay, so let's say there was a bit of traffic and then it sped up. So this one is at a rate of 55. When you have miles per hour, it is rate. And then the other rate was 70. That's the other rate. Okay. So I'm going to fill out the chart, even though it's super tiny. That was my bad. Okay, so part one, I'm just going to part one and part two. All right, so the first rate, traveling at 55, the other at 70. Okay, the total distance is 372, total of 6 hours. So I think that's all I have, right? You have to multiply r times t to get distance. And so I need to know what I'm multiplying here in order to get distance. I don't know what this is, but I know that the total time is 6. So you're going to let t equal time. Or let's just let it be x, because my t sometimes look like pluses, and then I have issues with that. So let's just let it be x. So it means that, and you always draw a line right here, it means that if I let this one be x and the total number of hours is 6, this box will be 6 minus x. Just think about it. If the total amount of hours, let's suppose that you went running, was 6 hours. 2 hours you were walking. How many hours were you running? The remaining 4. Okay? So I would take 6, subtract 2, and that would give me 4. So if I have a total of 6 hours, the first hour I don't know, but whatever it is I subtract from it, that will give me the second box. And that gives me these boxes, which I then multiply. 55x and then 70 times 6 minus x. I will rewrite it down here because it's super tiny. So that's 55x plus 76 minus x equals 372. So I'm solving for time. Let me zoom out just a bit. Okay, I'm going to distribute and solve it for x. Okay, so I'm going to have 55x plus 70 times 6, 420, minus 70x equals 372. The question is, how long did the car travel at each speed? How long means time. So these two I'm going to put together, and then I'm going to subtract the 420. Okay, so I'm going to take 55 and subtract 70. I should not be getting, at the final answer, I should not be getting any negative answers. I could get negative answers in the intermediate steps. So I get negative 15x when I put these two together. And then when I take 372 and I subtract 420, oh dear, 372 minus 420, that gives me negative 48. So yes, I will have negative intermediate steps, but then I divide by a negative 15, and that gives me a positive number of 3.2. X was hours, so time at 55 miles per hour. So this is the time in hours that it took for part 1. How long did it take for part 2? Let me zoom out just a bit. Oh gosh, I'm going to this is X right here. So in order for me to figure out the part 2, I'm going to take 6 minus 3.2. And that'll be the amount of hours that I would have gone in part 2, which is 2.8 hours. Oh, at part 2, which would be at the 70 miles per hour rate. So we're writing crooked. Well, the camera is slanted. All right, so when you are doing these, pay attention to this right here. Fill everything out. Notice that R times T is always D. That's maybe another equation that you might want to write. I will be composing an email and sending it out to let you know which questions are on the test. There are a total of 42. You have 2 hours to do them. Don't worry, like not all 42 is work that you have to do diligently. Only some of the problems require work. Some of the other problems are very simple, like put this in interval notation and I'll give you a graph. Just like that, page 13, you want to have that handy. So please make sure that you are doing that, that you are also composing your review sheet, 8.5 by 11, and you are uploading it to Canvas as soon as you are ready to go. All right. I'm just putting everything together. I will be sending out an email with all the information, like I said, and on Thursday you can come and ask me any questions you might have. All right. That ends everything for chapter 2. This is way crooked because my camera's crooked. I'm going to stop the share now. And I'm going to stop the recording. Thank you so much. Bring your questions to me on Thursday. And good luck making that review. We will talk more on Thursday and next Tuesday. All right. Good night. Bye-bye.